Now here is our final problem. It's related to boundary layers, and it discusses a particular quantity which we will introduce later on in the class. We will discuss boundary layers in about 3 or 4 weeks, which is the momentum thickness. And to solve this problem, you have to thoughtfully choose your control volume. So here is our problem. Let's assume that we have a uniform flow field, so velocity field. This is what is represented here. So the velocity does not depend on y and has a constant value which we call capital U. And now this flow field starts to flow above a flat plate, and we do take into account the effect of viscosity, and therefore we have to impose a no-slip boundary condition at the wall. So here the velocity at the wall is 0, and therefore it develops what is called a boundary layer. Now we'll assume that the flow is not driven by a pressure gradient. That means that at least far away from the boundary the pressure is constant, and we'll call the pressure PA, so atmospheric pressure, and we will discuss this later, but within a boundary layer there are no pressure gradient in the y direction, and therefore we can actually assume, so you can assume, that the pressure is constant everywhere. So we have no pressure differences anywhere, and the pressure we'll call PA. Also the velocity, so the velocity is uniform and equal to capital U at x equals 0, but at every single location, if y goes to infinity, the velocity will also be equal to capital U. And now the question is the following. We want to show that the momentum thickness is related to the drag on the plate, so the shear force on the plate between 0 and x, and the momentum thickness is defined as follow. At every single location x, we can define the momentum thickness if we know what the velocity profile is at that location, so u at x as a function of y, and it's equal to the integral between 0 and infinity of the velocity divided by capital U times 1 minus the velocity divided by capital U. So again, here I want you to think about which principles you have to apply, and also about which control volume you will pick in order to answer the question.